Hello everyone, welcome back to the channel. So today we are doing lead code 2044, count number of maximum bitwise OR subsets. So let's have a look at what the problem statement says. It says you're given an integer array nums, so something like this, and what you have to do is find the maximum possible bitwise OR. Alright, find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with that particular maximum bitwise OR. Alright, so the first thing that we are going to do is calculate what the maximum bitwise OR is. And something that we know, something that we understand about the bitwise OR, one of its property is that, for example, when you take two numbers xy, you calculate their OR, let's say their OR becomes xy. Now, whenever you are going to OR this particular xy with any other number, let's say a, this particular thing is not going to decrease. It's either going to remain the same or it's going to increase, right? So, or either remains the same or it sort of increases. It never goes down. So, for example, if I'm saying 5 or 3, or I'm saying 5 or 9, right? So it's either going to remain the same or it's going to increase. Over here I have 5, okay, and 3 is this. So if I do 5 or 3, it's going to become 7. If I do 5 or 9, 9 is this and 5 is this. So you see, again, it's going to be something which is greater than 5. So or whenever you have a certain number and when you OR it with some other thing, it's either going to increase or remain the same. Now, an array A, we know what a subset is, right? A subset of an array B, if A can be obtained from B by deleting some elements of B, blah blah. We know what a subset is. So what we essentially have to do is first of all calculate the maximum OR. Now, I have taken as an example this particular test case, and if I calculate the maximum OR for this one, it's very clearly going to be 7, right? So if I do the OR of all the numbers, or if I just do the OR of 2 or 5, or 3, 2 or 5, or 3 or 5, so you already, you're seeing that we have a lot of possible options and all of them are correct. So how can we find out the number of different subsets with the maximum bitwise OR? So I need to calculate the subsets such that they have an OR value of 7. Now a subset can be 3 comma 5, sure, right? A subset can be 2 comma 5, this one can also be there, right? What else? I can have similarly 3 to 5, right? 3 to 5. Similarly, I can have 3 to 1 5, isn't it? 3 to 1 5. What else can I have? I can have 2 1 5 and I can have 3 1 5, right? So overall I can have 6 subsets such that their maximum OR is going to be equals to 7. Now how was I able to come up with all of these values? Let me tell you. So we need to make sure that our maximum OR is equals to 7, right? We need to make sure that our maximum OR is equals to 7. And if our maximum OR is equals to 7, I need a 1 at all of these places, at all of these individual places. So what I'm going to do is I'm going to think of in terms of combinations. Now, what does that mean? So what I'm saying is, okay, I'll take this one. Now, if I take this one, what options do I have in this particular row? I can either take this two or this one. So for now, let's take this particular one. Okay. And again, since I've taken this and this, now I have 3 options. So what I'm going to do is I'm going to take this one. So what is this? This is basically I'm taking this particular bit, this particular bit, and this particular bit. So essentially what I'm doing is, sort of saying that, okay, let's take 5 and 3, because I can observe that one I'm taking from 5 and similarly from over here. So if I choose this particular combination, I'm going to get a 7. Okay. Now let's say, okay, not this combination, but I can take this combination as well. So this is the second combination, and similarly this is the third combination. And just like you saw that there were 3 possible combinations for this particular one. If I choose this particular one, there are also going to be 3 combinations, right? And over here, if I had one more on bit, I could have doubled the answer. But over here, I just have I just have this single one. So that's why my ultimate answer is going to be 3 plus 3, which is equals to 6, right? So this is one thing which is coming up into my mind, right? But we do have other test cases as well. So for example, if I look at this, we have 3 1 and 2 2 2. So we have 3 comma 1 and we have 2 2 2. Now what I say is that whenever you are working with bitwise, the first thing that you do is just represent the bits. Okay, forget about everything, just represent the bit. So whatever you are given, whether you are given an array, whether you are given a number, just represent whatever thing that you have in bits. What I'll do is I will represent 3 and 1 in bits. So 3 is just 1 1 and this is 0 1. Okay, similarly I have 1 0 1 0 and then 1 0. Now what I'm saying is, okay, the maximum bitwise OR of this particular array is going to be 3. Now how many subarrays can I have such that those particular subarray give me an OR of 3? So I can have 3 as a subarray, and then I can have I can have 3 comma 1 as a subarray. So why don't I do something like this? So if I choose this particular one, I can choose this one in order to make 3, right? And then if I choose this particular one, I can also choose this particular one. So this way also I get a maximum OR of 3. So what I'm getting an answer is 2 from this method as well and from this method as well. So this approach came up into my mind for the first and third test case, but then when I look at this particular test case, the answer for this test case is 7. So what I thought was, okay, if all the numbers are same, what we'll just do is we'll return 2 to the we'll return 2 to the power n minus 1 as it is. As simple as that. Why? Because n, by the way, is the length of the array in this scenario, which is 3. So 2 to the power 3 minus 1. What we are saying is basically, if you have all the numbers equal, then the answer is just going to be all the subsets, and all the possible subsets are 2 to the power n minus 1, right? So this was the first thought that came up into my mind. But the question is, would it pass all the test cases? It certainly wouldn't. Now how do I know that? I know that because when you implement this into when you implement this into code, let's for example take this example, right? 1 1 2. Let's take this example. I have 1 1 2. Now what I'm saying is okay, what I'm thinking right now is this. So what I'll do is first of all represent all these as bits, and then I'll see, okay, the maximum OR over here is what? It's 3. The maximum OR is 3, right? What are the possible answers that you can get? Okay, let's take this particular one, and with this one you can take this particular one. So 1 plus 1 gives you 3, right? So this is your first option. And if you don't take this particular one, you can take this one. That's your second option. So the answer for this test case should be 2, because there are no other possible choices that you can have. But then if you think about it, you the actual answer for this test case is 3, right? How? Let's see. So what we are saying is that the maximum possible OR for 1 1 2 is 3, right? Because if you sort of OR all of them, if you OR 2 or 1 or 1, if I do that, I get 3. Obviously 1 1, I get this. Now one possible subset is the array itself. One possible subset is the array itself, that gives me 3. Another one is this one and 2. So uh, but no, we are talking about subsets, right? We are not talking about subsequences. So they're saying subsets, and subsets are always contiguous, isn't it? Subsets are always contiguous. So no, actually they are talking about subsequences. So you see 3 comma 5, 3 comma 5, it's not a subset, it's clearly a subsequence. So I don't know why they have written subsets over here. They should have written subsequence. But anyhow, so what we are going to do is we are going to say this is possibility number 1. Then if I take this particular one and this particular 2, that is possibility number 2. And then if I take this particular one and this particular 2, that is possibility number 3. So the overall answer, as you can see, according to my logic, the answer that I was getting, according to the logic which I just showed you, was 2, obviously. But then the expected answer was 3. The expected answer was 3. So what can we do? Now, the thing to notice over here is that we have a very low constraint. We have a very low constraint. Nums.length can be at maximum, it can be 16. It cannot be, longer than that. So why don't I brute force it? Right. The question is asking me, what are the possible subsequences that give you the maximum OR? The question is asking me just that. It's not asking me anything other than that. It's asking me what are the possible subsets, what are the possible subsequences actually, which give you the maximum bitwise OR. So why don't I try all the possible sequences and see which of them are giving me the answer, which of them are not. So for example, if I continue with 3215, if I continue with 3215, so what I'm going to do is literally brute force the solution. Okay, I'm not going to think of any optimality since the constraint is so low. I'm just going to brute force the solution. So what I'm going to say is, okay, let's go with the standard approach. Now, whenever we are asked to find all possible subsequences, what do? This is something that we know at this point, right? Whenever we are asked to find all the possible subsequences, we take an element and explore, and we skip the current element and explore, isn't it? So let me tell you what I mean by this. So for example, if I have 3215, right, I'm starting with this array. What I'll do is I'll take a 3. Over here I'll not take anything. Similarly, from here what I'll do is, right now I'm over here, so I'll take the 2. Over here I will not take the 2. Over here I will take the 2. Over here I'll not take the 2, right? Similarly, from over here I will take the 1. Right now I'm at 1. I will take the 1, it becomes 3 to 1. I will not take the 1. I will take the 1. I will not take the 1. I will take the 1. I will not take the 1. I will take the 1 and I will not take the 1. So you see, let's forget 5 for a second. 3 to 1, it should give you how many subsequences? It should give you 2 to the power n, yani 2 to the power 3 subsequences, including the one which is empty overall. So basically 2 to the power 3 minus 1 non-empty subsets. Number 1 is this, number 2 is this, then this, this one, this one, this one, and this one, right? So this is exactly what I'm going to do, but not just that. What I'm going to do is, since I'm generating all the possible subsequences, I'm going to simultaneously calculate their OR values as well. And this OR value, I'm going to compare it with what? You guessed it correct. With the maximum OR value, which I have already, you can say, pre-computed, which I already have. So this is all that I need to do, right? This is all that I need to do. For example, if I had 3 to 1, now if I have 3 to 1, it looks something like this: 1 1 1 0 and 0 1. So if I calculate the maximum OR, it's going to be 1 1, which is 3, right? And then what I'll do is, I will at each and every point I'm going to see, okay, what's the OR value at this point, right? What's the OR value at this point? So the OR value at this point is 3, right? The OR value at this point is 3. It's 3 over here, it's 3 over here, 3 over here, 3 over here, 2 and 1, 3 over here, 2 over here, and 1 over here. So the overall answer for this particular test case is going to be 6. Why? Because you see, at the base case level, I have 3 subarrays such that their OR is equal to the maximum OR that I have. No, not 6, actually 5. 5 would be the answer. And if you think about it, what would be the possibilities? 3 to 1, right? Similarly, 3 2 and 3 1. What else? Just an individual 3 and 2 1. Perfect. So these are the obviously the five possible answers that I have for if I had 3 to 1 as a test case. So now what we are going to do is we are going to implement what we said in our coding environment. Okay, let's see how we can do this. So it's very simple, right? What I'm just going to do is, first of all, I'm going to pre-compute the maximum or. How can I do that? I'm going to say, okay, int max or, initially max or has a value of 0, and what I'm going to say is, okay, for int I in nums, what you need to do is just, or all the numbers, or equals I. This is how you're going to calculate what the maximum or value is. Now I will just return, if first of all I need to take care what index I'm standing at. So I'm going to send 0. So I'm standing at index 0. I'm going to send in nums. I am going to send what is the current or value, which is initially 0, and I'm going to pass in what the maximum or is, right? Over here, what I'm going to do is I am going to receive all of them in a function, integer solve, int I, vector int n percent nums, right? um and then I'm going to say, okay, what is the current or value, and I'm going to say what is the maximum or value, right? Perfect, this sounds good. Now what I'm going to do is I'm going to first of all uh, make the take case. So the take case is going to be something like this: one, not one, sorry, it's going to be solve I, you go to I plus 1 nums. Now the current or, if I'm taking an element, I don't actually need to, if you think about it, I don't actually need to, uh, you can say, I don't need to maintain the whole state of the array. I just need to calculate what the or is. So what I'll do is I'll say, okay, just do this current or whatever the current number is, which is nums of I, right? So that is how basically I am on the run, I am updating the current or value, right? By doing the bitwise or with the current number, and maximum or remains as it is. So this is what take, and skip is going to be, okay, just move on to the next number. um Move on to the next number, nums remains as is, current or remains as is, maximum or remains as is. And you see, the answer for the overall answer was 5 for this particular test case. So this is a valid one, this throws 1. This is valid, this throws 1. What this is going to throw upwards is actually take plus skip, so 2, isn't it? So what I want to do is I want to see, okay, how many possible subsets do I get when I take the current number, and how many do I get when I skip the current number. That's it. And the base case is going to be very simple. If your index, if it's greater than equals to nums dot size, then what you just need to simply do is check. You need to check whether the current or is equals to maximum or not. If it is equal, you return 1. If it's not, you return 0. So if I run this code, let's see if it passes. It passes the example test cases, and if I submit it, it passes the overall test cases as well. Now, if you think about the time complexity, this is clearly O of 2 to the power n. O of 2 to the power n time complexity, and the space complexity, you can say we're not taking any extra space per se, but then the recursive tree, obviously it's going to allocate some space for itself from the memory. So you can say the space complexity is the recursive stack space, right? You can say that, right? And why did we go for the O of 2 to the power n approach? By looking at the constraint. Since the constraint was very low, it clearly told us that if you do the brute force, it's going to be accepted. If it is, just go for it, right? So I hope you found the video helpful, and I will see you in the next one.